Hello. Okay, now it works. I should have a much better microphone today because I'm using my earpods as opposed to my AirPods. Um, I don't know if I want to do standard mic mode, maybe. Let me just quickly check in, see how the stream is doing. Yeah, this seems fine to me. Yeah, this seems fine to me. I mean, there is a bit of a rustling of the microphone. So this might be better if I move around a little bit. Yeah, it's fine. I'll do this one. Okay. Um, Now let's put on some music right here. I think I'm going to play something different today. Bit more upbeat per se. Might be a little loud. Because I got such a professional setup here, I'm going to once again listen to my own stream. How am I going to do this? Okay, I'm going to say something and play some music at the same time. And then I'm going to very quickly stop playing the music and then head over to the stream. Okay, that's fine, I think. We got it. Enough setup. Now I'm just gonna set up enough audio setup. Now I'm just gonna set up my windows in the right manner. Okay. Got a lot of stuff open here today. Okay. There we go. I think that's everything. Documents project, Azimuth code, open VS Code. I do have some new insights to share on day 13. And I also might have to walk out of this setup every once in a while to turn on the lights in the room again. I'm at the WeWork and there's nobody else on this floor. So the motion sensor sometimes needs to be triggered to keep the lights on. All right. Now, last thing I need to do is go to my stream manager and pop out the chat. This is going to be somewhat of a longer stream because I'm going to do day 13 part 2 and also day 14. So let's see how that goes. All right, windows are all set up. This is what we're working with. And I already got ChatGPT open on the other space right here. Okay. So here's what I'm thinking, all right? We have two equations, A x1 plus B x2 equals let's call it D. And then we got D, E, F. So basically, no, let's do this differently. Let's call these A, B, C, D. And then let's call these S1 and S2. So basically, this is just the matrix A times the vector x is equal to S, right? So I want to talk to ChatGPT and see what ChatGPT has to say about this. Say we have a set of linear equations. Or in matrix form with A being a 2x2 matrix and X and S being, do you call them 2x1? I think you call them 2x1 vectors. Now we want to solve for the vector X. There are three cases. Either there is no solution, or one, or infinitely many. Let's start by determining which case we're faced with. I don't think I want to write any code. I want to implement the code myself. How would we go about doing that? There we go. So we need the determinant of A. NumPy lin elk det. All right, let's do this. So I think we can still keep this one for history's sake. And now we're gonna do import det from here. Nope, that's not how Python works. This is how Python works. All right. So we have A, B, C, D, and then we got S1 and S2. And then we have, yes, I think. That does look about right. Well, let's do this the proper way. If det of A equals 0, continue. Is that right? Did I just close my stream? I hate that it's like foregrounding OBS every time I switch to this space, but it's fine. We'll work with it. That's right. Not invertible. And the vector S lies in the column space of A. Step to determine the case. There's a unique solution. Check for consistency. Substitute into the system. Check the rank of the augmented matrix compared to the rank of A. What the heck? What even is this? The augmented matrix. It probably means we're attaching, we're just, concatenating the columns. Augmented matrix. is the matrix formed by combining the coefficient matrix of a system of linear equations with the constant vector on the right side, separated by a vertical line, essentially creating a single matrix that represents the entire system of equations, allowing for easier manipulating using row operations to solve for variables. I see. Okay, but what about this friggin' line? The line doesn't go into a friggin' NumPy. Ugh. Well, this one we called S, right? So AS is equal to MP array and we're attaching S1 and S2. All right, and now we need to figure out the rank. NumPy rank. Matrix rank, that sounds about right. So we import that and matrix rank. So now we check if the rank of A is equal to the augmented. If the rank is less, then there's no solution. Let's see. If rank of A is smaller than rank of AS, then there's no solution. And then else, infinite solutions. Great. So let's start by running this against the input. So X and Y, I think we need to attach, or we need to add a very, very high number to. Is this actually in 64? Yeah, by a couple of orders of magnitude. So we should be fine. So let's do in 64. So every array, we need to specify D type int 64, I think, right? I think this works. Yeah, I mean, we didn't crash it, so I'm assuming it works. All right, so we invert the matrix. It's probably this method. Compute the inverse of a matrix. And I think then it's the inverse times S gives us X. Is that right? Yes. So X is equal to the inverse of A dot S. You got it. And then we print X. And then, yeah, S1 is equal to S1 plus this very long number. And then the same holds true for S2. So we should get this. Why is this not an integer? That kind of sucks for me. That doesn't make any sense. We're only working with integers. Let's see. So what values are we putting in here? 94, 34. 94, 34. It's only possible to win a prize on the second and fourth claw machine. Alright, so if x0 is integer, yeah. So let's instead do a not or return. No, continue. No solution. No solution. Let's see if we get a solution for this one. There might be infinitely many, of course, which we haven't implemented yet. You know what? I can just do this. Ooh, well, that's not good. Why are you saying that there's no solution? Probably because it's like really close to being an integer, but not really an integer. We got x0 and x1. Ooh, it's not that close, to be quite honest with you. Not that close. It's not that close. I mean, we're working with... All right, how does the inverse work? Let's see what ChatGPT has to say about this. Is it possible when working with large N64 numbers that NumPy's linalc inf method returns non-integer double values where there should be an integer solution? Are we losing accuracy? I see. I see. All right, so we could do SymPy instead, I guess. We still need to do the determinant and the rank. Ay, ay, ay. Can you convert all this to SymPy? Do these really have the same methods? Uh-huh. So we still get no solution. I mean, I'm assuming this is not an integer. It's not. Okay. Interesting, interesting. Oh, I mean, I'll have to look at this one. Yeah, still not an integer. Huh. That is very interesting. Well, let's keep this one in the back of our mind. But let's work with NumPy for now. I think we can assume that NumPy would have found this one. I mean, look, even the precise algebra answer didn't quite work. So it's not a NumPy issue, I don't think. Let's check. Oh, you know what? I might be a huge dum-dum. I'm adding the large number twice. Okay, well, unfortunately, that's still not quite right. So let's see what we get for A and S. We get... I don't know if this is, you know, transposed. It might be. But I don't think so. Because I'm pretty sure... Anyway, let's see what we have here. So 26, 66, 67, 21. Those are all correct. And then you multiply it and you get this number and this number. So I guess we will try SymPy again. And it might just magically work, but I don't think it will. Because that would be kind of insane. That would be kind of insane. No. It's not right. It's not right. Unless... No, that's not right. That's not right. Okay. So what are we doing wrong? What are we doing wrong? Now it's only possible to win on the second and fourth claw machine. Wait, what the crap? This has to be up here. Jesus. Oh man. Oh man. I wish I knew what I'm doing wrong. I wish I knew what I'm doing wrong. Okay, let's talk it through. We have an array of values that we're turning into a NumPy matrix. We got the right values in that matrix. We also have a vector of values that come out of the equation a times x equals s. So we are inverting a and multiplying it with s, which not only ChatGPT told us to do, but also sounds incredibly accurate and valid to me. Times here is the dot product. There's no question about it. There's no question about it. Okay, let's see what this little guy has to offer. Is it not the dot product? Am I not supposed to do the dot product? I'm pretty sure that the add symbol is just the dot product. Yeah, it's the same result. The solution print x. Oh man. I'm gonna take one very quick break, and I'll be back in just 1 second. There goes my camera. Is it gonna fix itself in terms of the view frame? I look very differently centered than I did before. Wait, 1 second. It is very bizarre that it's suddenly so different, but it's fine. We'll work with it anyway. I still have like absolutely no idea what's going on here. I wish I knew. Why this isn't working, because I think there's like some very obvious candidates for why this isn't working. Namely, you know, precision, which I try to sort out by using SymPy. There's, I guess, a tiny chance that ChatGPT changed the method to SymPy and broke something about it. I mean, how many zeros are we talking here? 1, 2, 3, 4 groups of 3 plus 1. Let's just turn every group of 3 with an underscore and then move 1 to the front. Yeah, I mean, that's the exact same value. It's 4 groups of 3 plus 1. So that's not the problem. This is also exactly what I did before. I might have to transpose my matrix, but I don't think I do. Look, I mean, we can just try transposing it. But it will not, like, there's a 0% chance that this suddenly works now. What if we printed the non-integer component of our numbers to see if maybe there's like a very obvious difference between these two, but there very much is not. In fact, this one is closer to being 1 than this one is. Ugh. How about we just take all of these and see if maybe we find a solution for any of them. No solution, no solution, no solution, no solution. Huh. Yeah, I'm sort of, I don't know, I'm sort of done with my idea. I thought this was gonna work, but it's not. We got 94, 34, 22, 67, one a lot of zeros, and 84, 00, and 54, 00. So that's all right. That all looks amazing to me. Wait a second. I do have to transpose it. Because yes, I do have to transpose it. Because the first one is for the x, the second one is for the y, but we don't add these two together to make this. We add this one and this one together to make this. Yes, okay, great. So now we check if the error is... Okay, let's try the SymPy one again, because well, first of all, let's remove all of these. That'll be a manual process to remove these because we don't want leading zeros. Okay. So let's do this again. And now we transpose this, and now there will be a solution. Yeah, there we go. Nice. Okay. So we take this times 3 plus this. And we add it to the sum, maybe. And then we print s. I don't think this will work. Oh, it did. Okay. Well, that's part 2 done. I guess it was much easier than I thought it was going to be. There were a couple of curveballs in here. And I'm a little sad that we didn't even have to optimize anything about the whole thing. But yeah, it was in fact just a system of linear equations. I'm a little sad that, you know, this part is where they could have done better, I think. I think having one with infinitely many solutions would really, like, the way they describe the problem really lends itself to that. But yeah, anyway. All right, we do not want to print these. We just comment them out to have a clean output. And then we add part 2. Great. Let's close out of all of this and then do day 14. Let's see how tricky that one is going to be. It's true. I mean, I think it's as optimized as it gets to use like an algebra library to solve this set of equations. Like, honestly, I think yesterday's puzzle, you know, all in all, was pretty boring. Because the way it's phrased sounded like the meat of it was going to be completely different than what it actually was. I did really like some of the other days this year. Let's see what day 14 holds. Okay, we got robots at a position with a velocity. The robots outside the actual bathroom are in a space which is 101 tiles wide and 103 tiles tall. So 2, 4 is 2 to the right, 4 down. Yeah, 12 was really nice. I was really happy with 12 too. I really did like 12. Okay, so why is this little guy going up and then down, and then up and then down. 2 minus 3. So it goes right and up 3. That makes sense. And then it pops back out at the bottom, I guess. They teleport to the other side. Yep. Yeah, I just saw that. The historian can't wait much longer, so you don't have to simulate the road very long. Where will everybody be in 100 seconds? Count the number of robots in each quadrant. Got it. This example, blah, blah, blah. Multiplying these together gives a safety factor. All right, that should be very easy. So what I'll do is create a NumPy array. 101 and 103. So we got N and M. And then we need to parse this as like a... I think what I'm gonna do is replace this with a comma. And then I'm gonna replace E equals with nothing. And then we gotta split by comma and turn it into ints. So I think if I print this, we should be able to get the first 4 values of my input, which is this. All right, so let's see. In range 100. Well, I think I want to have a set of P, which is X, Y for X, Y underscore in T. And then we want to have V for underscore T. We might have to do parentheses around these. No, we don't. Okay. So for X, Y, and P, and I think I want to enumerate this. And I think then it's I XY, and then XY is equal to XY. This might work, I think. How about we just do P of I, and then we do for I in range of len of P. And then we gotta mod this by M, and this by N, perhaps? And then for X, Y, and T, if X greater than M divided by 2, we got the quads, which is just 4 zeros. And then we check for Y smaller than N. Else do 2. And then here we have an else case, which has 1 and 0 in it. There we go. And then we print Q 0 times 1, 2, 3. Let's see if this is right. Too many values to unpack. You are right about that. I forgot a comma. Too high. Okay. That wasn't right. Let's see what we did wrong. Let's see what we did wrong. Let's take the test input. Put it right here. 0. That is a little bit surprising. In fact, that should be impossible. So I'm not doing something quite right here. So the test size is much smaller. We're supposed to have 101 wide, which is the X value. Yes. No, I did it the wrong way around. So I have a feeling this just might work, perhaps. A little too high. Okay. So it's n times m is the size of the whole thing. So it should be 101 times... You know what? This is getting too confusing for me. Well, let's call it big X and big Y. So we have 101 wide, 103 tall, X and Y. And then we have large X and uppercase Y. There we go. We already gave this answer. Okay. So I did have it right the second time around. Okay, so now we have 11 and 7 for the test values. 11. And 7. Well, let's see. Why? What do we get here? 45. How about we print it all out? We got an array of 0 for underscore in range of X. For underscore in range Y. For X, Y, and P, YX equals 1. And then we print A. We print new line dot join A. String of I for I and A. I see. This should be better, perhaps. Okay. There we go. Okay, so now we got the right output printed. And this does appear to be the right simulation, but I'm not doing the math right. So why is that? So this index here, for example, this number, I think it's not supposed to be a greater than. I think it's supposed to be a greater than or equal. We still have 36, which is larger than what we're looking for. So let's see. We got 1632, and it's an actuality 1341. If x greater equals to x divided by 2. So let's say we have a grid of 4 by 4. 4 by 4. Then the index here is 1, 1. So we want 2, 2 to be in the upper quadrant. Yeah, so I think this is right, because 4 divided by 2 is 2. And if the index is 0, 1, 2, that's greater or equal to this value divided by 2. So what's your problem? Is the sum of values even right? You might be right about that. Robots that are in the middle. Wow. Okay. So we add 1 to this. And okay, wait. No. It's an odd number, right? So 11. We're eliminating. Let's see. So this would be 5 by 5, right? So for 5 by 5, 5 divided by 2, rounded down is 2. And the index is 2. Okay, so how about we do not greater than or equal, but greater. And then every else is instead an elif, which is less than. And this has to be an x and an uppercase x. Whoops, gotta remove these. There we go. 12 sounds about right. Okay. So let's return to the real dimensions and solve it. During the bathroom break, someone notices that these robots seem awfully similar to ones built at the North Pole. If they're the same type of robots, they should have hard-coded a hard-coded Easter egg. Very rarely, most of the robots should arrange themselves into a picture of a Christmas tree. What is the fewest number of seconds that must elapse for robots to display this Easter egg? Well, that should be pretty easy. That should be pretty easy. Ooh, aye. Let's see if my terminal is wide enough for this one. It's not, probably. I mean, how many characters are this? Come on. Does it print at all how wide it is? Yes. Okay, it's 200 wide, so it is wide enough. So let's just do this, but wait for user to hit enter. Let's see. Okay. I stand by that. But it might be a very large number. So how would we determine if something is a Christmas tree if we can't just look at it ourselves? Excellent question. Excellent question. I think it's move +1, right? Because this is after this many seconds. How far am I gonna go? I think I'm gonna go to like 200 maybe. This does look like it's gonna be a very large number. So while we look at these robots just move around, we might as well think about how we might be able to determine this programmatically. Probably we would look at the surface area of a continuous blob of these robots being a new record, right? And every time that happens, we print it. And then we take a look at all of these new records. We just wrote an algorithm for surface area before. That should be doable. Is that a good idea? That might be a good idea. Like with every iteration, we look at the surface area of A. This was day 12, right? So this is how we calculate blobs. Yeah, I think I stand by that. I think I stand by that. Let's give it a try. Why not? Okay. Def area of A. So T is now A. And we just take a look at the first blob that has a 1 in it, maybe. No, that feels wrong. Let's just take a look at every blob that doesn't have a 0 when joining, and we calculate the max. Max area equals 0. All right. We do have to fix the movement vector. Okay. There we go. Yeah, I mean, I'm just thinking about it because that's what we did for day 12, right? So I think this is where joining happens, right? Yes. So we take the new blob index. All right. If a xy is not 0 and the length of this is greater than the max area, then the max area is this. And then we return max area. I think this should work, hopefully. So we keep track of max area. And then if area, okay, wait, new area is equal to area if we are max area, print new area and move +1. I think it's move +1. It might also be move. Not sure. Let's see. Join size is not defined. Yes, you are correct about that. All right. Um, 52 sounds like a lot. No, the area is 3, I think. I think we started with an area of 2. Then we moved to an area of 3 at move 52. Maybe? I feel like this is taking very long. Like much longer than I would hope it takes. Print new max. Like I feel like it takes this almost like a second per iteration here. Yeah, that's too slow. That can't be right. How about we just continue if it's 0? That might make it much faster. Yeah, there we go. All right. Well, I hope that this approach is fast enough to get us somewhere. Oh, 4 is not very high. Let's do better. So what I'm doing is I'm looking for the biggest blob of numbers that are not 0. And every time we find the one that's bigger than the highest blob we found before, we return it. This is, oh, max 5 is also not very large. Okay, you know what? I'm gonna remove the print unless if move, yes. There we go. All right. So I think this is going to find it, and I think it's going to be very slow, but I think it's going to be fast enough because I doubt that this is going to take more than like 10,000 moves. Because I think the approach I have is already like pretty optimal. And then, you know, once we solve it, we can just... oh my gosh, I'm an idiot. Wait. For move +1. Okay. All right, I think, yeah, what I meant to say is that I think this is going to work to get to the answer in like a reasonable amount of time. And then once we have the answer, we can take a look at what a Christmas tree looks like. And then write a better algorithm to detect it. Like, I expect it to be like, you know, if the amount of robots in line 50 is, you know, greater than 10. I don't know. I'm just saying random numbers, right? But I think that's the best way to detect the Christmas tree. We almost have to write like an OCR algorithm for detecting Christmas trees. I remember when one of the puzzles in the previous Advent of Codes was like doing this kind of stuff with like folding a piece of paper many times, and then it would create letters like in a pixelated form in a grid, and you had to print out the letters as your answer. For that day, I did write like a super shitty pseudo OCR in Python to detect what letters were getting printed, so that my code didn't just work for my input, but for all inputs. So that was my goal. All right, well, I'm starting to get a little nervous because we already did this 24,000 times and we haven't found a Christmas tree yet. Is there still somebody in chat who did Advent of Code and who can give me a ballpark? Like, are we talking tens of thousands? Is it more than 50K? Is it hundreds of thousands? How long do I have to sit here and run this? Below 10K. Okay, so this is probably not right. A blob of 5 does not sound right. I mean, maybe it does. Let's take a look at this. And this is, I think, the printing I did, right? Let's print it out at the end. Let's see. I can see the blob, but this is not a Christmas tree. It's very much not a Christmas tree. Huh. That's not great. That's not great. Well, here's what I'm thinking. I'm thinking that we solved part 1 correctly. So this part of the algorithm has to be correct. And we're doing the exact same thing down there. The method to calculate the area seems to be working, because I do indeed see 5 numbers right next to each other. So there has to be, like, maybe the Christmas tree is not, like, all the robots aren't touching. That's what I can think of. So they form a sparse Christmas tree with gaps between the robots. Because otherwise, like, I don't see any scenario in which my solution takes 33,000, but other people's takes less than 10K. That doesn't seem right. Well, how about this? I'm going to speed this up a little bit, and I will do one if I don't know if this is faster. It's probably not faster. Never mind. It could be faster to keep track of the array for every iteration, but I don't think so, to be quite honest. So we kind of had a pretty optimal solution go. Okay, you know what? On the off chance that my code actually would have produced the right result, I'm going to keep this running. And then in a new tab, I'm going to start working on a better solution. So here's my theory. My theory is that it might be easier to detect the Christmas tree by saying, you know, what's the maximum amount of robots in one row? So we define a new area method. 999. And we let it rip. So the new area method is going to be return max of some row for row in R. Let's see. No module old numpy. You're wrong. Okay. So we had a maximum of 4 robots in one row. Damn, this also is not working. Am I skipping over some instructions? That is so strange. So strange. So there's neither a blob that they arrange themselves into, nor a line. That can't be right. What's going on? I mean, the line thing, I went all the way up to 300,000. And still nothing. That doesn't make any sense. The amount of robots in my printout does look pretty low. You're right about that. Yes. That's a great point you're making there. Excellent point. Wait, this is day 12. What am I looking at? You know what? I think I messed up. I think I'm still using the test string and not my real input. So that's most definitely why this is happening. So let's do this. Yeah. That's right. Well, thanks for pointing that out. I think it might actually be 52. Let's see if the blob method agrees. Oh. Let's try 52. 52 seems a little low. Yeah. That ain't a Christmas tree. Okay, well, let's go back to the blob method then, shall we? So I think that was this, right? This is the blob method? I think so. Okay. Now we see a max of 9, which I think did show up here somewhere. Yeah, I think it's like this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Something along those lines. Okay, we're up to 11. That still does not seem like enough robots to make a Christmas tree. Oh, 200. That's a lot of robots. Let's try 6644. Yeah, there we go. All right. All right. So it's 6644. Ding, ding, ding. All right. Thanks for pointing that out. I can't believe I forgot to remove the test input. Well, I think the way to solve this one programmatically for any input is probably, because I don't think we can go by lines, right? If we go by lines, there's probably ones like, you know, there's lots of robots in one line here. So I think what I'm just going to do is slightly rewrite this one and say if area is greater than, what do we get here? 200. Then we print and return. And then we remove this stuff. And I think if we run this now, we get the full picture. So now my code only produces 2 lines of output. One is the answer to part 1, one is the answer to part 2, and it should work with any input. But it will take a second. makes me wonder if there 1000% is a better way of doing this. We can probably be like, oh, how many yeah, there we go. I think the best way to do this might be to just check for like a continuous line. I think that's much more efficient than my code. But it's fine. We're not trying to win any runtime speed records here. At day 14. You know, my theory is that they had day 12 in there before day 14 to sort of prime you to think about blobs. That's my theory. All right, well, that was pretty fun. Very Christmas themed. I'm now caught back up with all of the puzzles, so I think that's gonna be it for today. Took a little longer than expected, especially day 13 took me a minute. But, you know, we get there, and that's all that counts. And I think that's it for me. Assume that tree is not perfectly centered. So I calculated the quadrants and looked for one that had an unexpected high count. Yeah, that's a great point. That's a very good point. That might also have been what they wanted you to do. To be honest though, my tree does look very, very centered. I'll give you that. I mean, maybe it's not perfectly centered, but man, it's very centered. At least vertically, it looks to be pretty much perfectly centered. Yeah, I would expect that to be very fast. It's a good idea, you know. I really don't like how slow my area finding code is. I just copied that one from day 12. So it only goes through every cell once, but it does have to go through every cell. See, I think, now that I think about it, my area finding code is incredibly inefficient, and I think it could be optimized by a factor of 2. Because, and I mean, I did live stream, let me just show you my code again. I did live stream on the 12th, and I wrote this code live. But like, we don't have to look at every direction. If we go through X and Y, we're already iterating through line by line from top to bottom, so we only need to merge down and to the right. Yeah, who cares? Who cares? I'm happy with where we are. I'm happy with the consistency of doing 14 days of admin of code. I am now up to 478 stars out of 500. So being at a good spot for being one of the first people to get to 500 stars. All right, thank you so much for the idea of checking the amount of robots. TC Arcus to Carcass. TCA. I'm gonna go with TC Arcus. That's probably the way God intended to be, that name, for that name to be read. All right, that's it for me for today. Might be back at midnight for day 15, otherwise probably back tomorrow. And I'll see you there. Bye-bye. Thanks for watching.